Imagine you examine a file system for anomalies and find numerous user files with a creation date in 1995. Would you believe in these timestamps or not? Let me give you an idea how to handle such cases. It's time for truth. We are dealing with the forensic analysis of NTFS timestamps. One of the challenges in forensic investigations is the reconstruction of a credible timeline. Criminal activities must be chronologically ordered in time to be able to understand the attacker's modus operandi. But attackers often use timestamp forgery tools to manipulate file timestamps, which aims to obscure the traces or to pretend false facts to avoid a possible finding of evidence. This anti-forensic method hinders the work of data forensic experts and makes it difficult to analyze the corrupted file system. There have already been several approaches for the identification of manipulated timestamps in the past. However, most of them have been around for a long time and do not reflect the current state of affairs. With this research work, we want to validate the available forensic reference documents and update them with the resulting findings. For this purpose, we follow two different approaches. The first part is based on the determination of permissible timestamp patterns caused by user interaction with the operating system and the installed applications. The second part examines timestamp forgery characteristics that can occur from the use of falsification tools. To facilitate understanding of the timestamp patterns, we have prepared this slide as an overview of existing file timestamps in NTFS. One of the core elements in NTFS is the master file table, where all files are listed. These are the so-called MFT entries or file records. Each file record consists of multiple attributes, but the most important ones for timestamp analysis are standard information and file name. Both attributes in turn hold a timestamp for the birth or creation of a file, the last access, the last modification, and the last change in MFT. For the sake of simplicity, we use these abbreviations. The corresponding timestamps in standard information and file name do not implicitly have to contain the same values. For the eyes of the user, only the three timestamps SCB, SCA, and SCM are visible. For example, in the file Properties in Windows Explorer. So let's start with permissible timestamp patterns. Here is an example for a file called sample.txt with its extracted timestamps. At this point, I would like to emphasize that all timestamps in NTFS have an exactness of 100 nanoseconds. This would be important later when we analyze the characteristics. But back to the patterns now. As you can see, all timestamps for file name hold the same value. Also, SCB represents this point in time. Therefore, we can assume that the file's birthday was on 21st of May this year. But the SC timestamps for access, modification, and MFT change show a later date. So this would be the resulting timestamp pattern in this case, representing a file modification on the 10th of June. When we are speaking about resulting patterns, we also can define a timestamp update rule. The term U means that the initial timestamp remains and will not change due to this file operation. TOP stands for the operation time of the event, while delta is an additional time period for performing the file operation. So the rule states that all FN timestamps will be preserved, also SCB remains the same, SCM and SCC will be adapted to the time of the file modification, while for SCA the processing time will be considered. As a reference for our investigation, we used the Windows time rules published by SANS Digital Forensics and Incident Response. This was one of the last available documents from the official site when performing our research. The table describes the timestamp updates triggered by certain file operations. If we take our example from the previous slide, we can determine that our results are corresponding to the information shown in this table. which means no change in file name and SCB, but modification of all remaining SC stamps to the time of modification. For the determination of permissible timestamp patterns, we define certain user files. In detail, text files, docx, xlsx, and PowerPoint files from the Microsoft Office family, PNG, GIF, and JPEG representing the image file class, and PDF documents. With this selection, we can take into account possible application-specific differences. In accordance with Sense Digital Forensic, we performed file operations for creation, access, modification, renaming, copy, move, and deletion. In concrete figures, we were able to achieve 45 different and unique timestamp patterns, grouped to 30 use cases. From these results, 18 timestamp update rules could be derived. These obtained research results serve as the basis for our permissible timestamp patterns table. This table can be used as guideline for forensic practitioners. Broken down to the file type, shown on the right side, it specifies possible permissible timestamp patterns with the update rule for certain file operations. If we remember our example from before, we can identify that the extracted timestamp pattern is a permissible value for a modification of a text file. I don't want to delve deeper into the results at this point, as this would exceed the time frame, but I wish to summarize the main findings on the next slide. Compared to Sense DFIR time rules, we were able to determine some considerable differences. These are mainly due to the application-specific deviations. The resulting patterns also allow conclusions to be drawn about the application used. Furthermore, the consistency of patterns isn't given even under application families like Microsoft Office. We observed several different results for Word, Excel, and PowerPoint files. Also, the approach to file processing can end in different patterns. For example, TXT file creation in Windows Explorer compared to PowerShell can produce different results. The timestamp for SEA must be judged with caution, as the special file accesses like virus scanners can trigger an update on it. In addition, there is a registry value in Windows which defines the update behavior for this timestamp. The last point to mention here is that we consider data resident and non-resident files. This means that smaller files can hold the data directly in the MFT entry, while bigger files would exceed the space limit. Therefore, the data will be stored in additional clusters in the file system. Nevertheless, this makes no difference in the resulting timestamp patterns. The second part of our research work deals with the identification of forgery characteristics in timestamps. Therefore, we classified available forgery tools based on their capabilities. The basic group contains of the application's new file time, SK timestamp, bulk file changer, express timestamp toucher, and timestamp forger, which is a custom partial script. With the help of the Windows API set file time, these tools can set the timestamps for both access and modification in standard information only. Remember, these are the only 3 file times which are visible for users. The intermediate class consists of timestamp and mtimestamp. Using another available Windows API allows them to alter all timestamps of standard information. But the existing Windows APIs do not support the modification of the FN timestamps directly. To achieve this goal, the advanced tool setMaze utilizes a kernel mode driver to write the tempered values directly into the MFT. With this method, all 8 file timestamps can be altered to any value. Additionally to their capabilities, all tools can be classified according to their accuracy. So let's have a deeper look into the basic tools. In general, it can be said that basic tools can set time values to whole seconds only. Using implemented functions, better accuracy can be achieved with some of these tools. But in these cases, the decimal places cannot be set individually. They remain from the original timestamp or will be set to a random value. One exception here is the self-written partial script timestamp forger. With this script, we demonstrate that it is possible to alter these 3 timestamps to any possible value with 100 nanosecond precision. As mentioned before, the intermediate tools have also the possibility to modify the MFT change date of the standard information attribute, which is hidden from the user. Timestamp is already an old tool originating from the Metersploit project. Its accuracy is limited to full seconds. The modern equivalent is N-timestamp, where the N stands for nanosecond precision. So this tool can set any timestamp value with the default NTFS accuracy in standard information attribute. ZMaze, as the sole representative of the advanced tools, writes the tempered values directly into the MFT. Therefore, it requires administrative privileges. For the system disk, test-signed drivers must be allowed, and data disks will be unmounted for the time period of the tampering process. Usually, the Windows security feature PatchGuard protects the kernel from this falsification method. ZMaze allows timestamp forgery of all relevant time evidence in SC and FN attributes, with an exactness of 100 nanoseconds. This possibility would reflect the original accuracy for timestamps in NTFS. As a result, we can summarize that truncation or cloning of decimal places in file timestamps can be an indication of forgery. But we shouldn't forget that there is the possibility of false positives when valid timestamps happen to fall on these values. In practice, only timestamps of standard information can be falsified, as the use of ZMaze is basically prevented by security measures. We have shown that current tools such as Timestamp Forger or N-timestamp support the standard accuracy of NTFS times. Together with the knowledge of permissible timestamp patterns, forgeries are therefore very difficult to prove. Thank you for letting me steal your time, and don't trust in every timestamp you see. My name is Galhuber. I studied IT security at the University of Applied Science in St. Pölten in Austria. And I'm happy to answer your questions now.